Hi, this is Russ Andersson with the first part of a three-part series on a typical sports stadium shot. This problem shows up routinely in our tech support area, so I thought I'd put out a little series on what's happening and what to do about it. So this is our basic shot, and it's a typical sort of shot that you might need to add some motion graphics to. So let's just do the naive sort of thing to it and run the auto tracker and see what happens. The first thing you'll notice here is that during the solve, the iteration count goes all the way up to 500. It's doing a lot of work, and then there's an error message or a warning message. It's not a crisp solution, it's using a safer algorithm. And the second iteration count is also very high. And you'll see also finally it changed 20 trackers to far with reduced weight. So all these messages that are stuck in here, the iteration counts and the length of time required, are telling you that things really haven't gone as well as you might have liked. So let's take a look at what we've got. And you'll see that here are the far trackers, and far trackers are only directions, not distances. The fact that there's so many of them is a hint that things have gone awry also. If you scrub through the shot, you'll also see that there are a bunch of yellow tracker marks that are kind of jumping around at random. So that's definitely a little funky looking. So now let's just continue blithely along and set up a coordinate system using a couple of these trackers that are on the field level. And again, there's a fairly lengthy delay there comparatively. And now if you look at the side view, here are all the far trackers. But here, instead of seeing a flat field, there's kind of stuff all over the place. And if you start clicking on the various trackers, you see that there's not really any particular relationship between things that are up close and things that are far away. Now, the key to this is to recognize that this kind of shot is typically shot from a fixed camera position. There's somebody up there on a little platform with a camera on a tripod. And we haven't done anything about that. We've tried to solve it as a regular 3D shot, and that 3D information just isn't there. So instead, we get a whole lot of garbage like this, and it's not going to turn out very well. So what we can do instead is now go and switch to tripod mode and tell it the camera's on a tripod. And if we hit go now, we're going to get an error message that says that there's a coordinate system set up, and coordinate systems can't get set up in tripod shots because there's no 3D. So I'll just show getting rid of that. This is just kind of a simple way to do that. I'm just taking each of those three trackers and setting it back to unlocked. And now let's run the solve again. And presto. Now I have a solve. It's got, around a 2-pixel error. It's probably mainly due to lens distortion and maybe to some of the stuff that is, a little bit close to the camera. So there might have been a little residual motion. But basically the fact is that I still have a pretty good solution, even though I told it, hey, the camera's not moving it at all, and I've calculated only directions to everything and no distances at all. So I have a solution, but it's not going to be one that's very handy for adding things into it. I can go and put things in, but because there's no coordinate system, everything will stick nicely, but if you want to do a true 3D effect in there, you don't have enough information yet. So the question is, what can you do about that? And there are two different, relatively straightforward ways to deal with this kind of shot. And I'll take a look at those in the next two parts of this series. But before we get to that, one other thing I'd like to show is that you might often see something that goes like this. And I'm going to use the image preprocessor to fake this up. And I'm just creating something in the Oops, I didn't do quite what I had in mind. You need to turn on the key there. So here's my shot now. Let's suppose this is what I gotten. And then, in one part of the shot, it looks like something's happening. So you might say, oh, look, the camera did move. It is really a moving camera shot. But no, really, you're just seeing the effect of a zoom that you can fairly easily mistake to be an actual translation of the camera. But the thing you have to remember again is that most of these shots at stadiums are from a fixed platform, and the cameramen have their fingers right on those zoom buttons. So this sort of zoom effect is quite common, and you need to keep in mind that that's probably what's going on. You need to tell SynthEyes that it's a zoom, not that it's magically suddenly a translating camera shot. So from here we'll go on to part 2. Hi, this is Russ Andersson with part 2 of our stadium shot example. So we're going to start over from the top here by just saying that we have a tripod shot. We're going to do an auto solve on it. We get that quickly. Here's our tripod solve. So what we want to do is position this whole shot so that we can add things in 3D with the proper field level established. And really what that amounts to is finding out where this camera is with respect to the field. And to do that, we're going to use the alignment lines capability on the lens panel and the single frame alignment feature. Now, before we do this, normally we should go and take a look at these trackers, make sure that we don't have any on any of the players or fans that are moving around. We're just going to skip that here. Let's just pick out a frame where we can see a bunch of these lines pretty clearly. We're going to turn on the Add Line button here and create some lines along the lines of the field. This first one is going to be on the x-axis, just about off the edge there. We can zoom in at each end here to make sure that we've got it positioned accurately. This is just using the middle mouse button to zoom in and out. Now we'll also go and add some lines along the main lines of the field. This will be, I guess, parallel to the y-axis. Again, we'll just position it a little. And this line is actually the 0 line. So this is the one that's going to be on the y-axis. Again, we'll just zoom in real quick and position it. And you can see I'm just doing it on one side of the line here because these lines are really pretty wide. If the lines were skinnier, you might go down the middle. Now, one thing also that I'm doing, you notice I'm not going all the way across the field. The reason for that is simple. Most sports fields are crowned, which means that the middle of the field is higher than the outer edges in order to cause rainwater to run off the middle of the field. So the lines are actually bent in 3D. So we're sticking just to kind of one half of the line, one half of the field to set this up. If we were going to add an effect maybe in the middle of the field, we might stick with just lines across the middle part of the field. Or, we might use this parts that I did where it's easy to see them, but just adjust the positions of things that are on the other part of the field a little bit to compensate for the crowning of the field. So once I have those lines set up, now it's just a matter of going and hitting the Align button here, and you'll see that the position of the camera has now changed, and the position of the and direction of all the trackers has changed. And if I go and add something into the shot, this is the 0, 0 point here, which corresponds to the 0, 0 that I set up here, but with these being the 2 axis lines. So if I create something over here, that's on the main part of the field. So now I can create things in the scene that are really on the proper field level, and this is the kind of alignment that you want and that you expect out of a 3D tracking system. But note that I really done it without having the distances to anything, and everything is based on just these couple of lines that I set up. And the thing to keep in mind is that because it is based on a lot less information, this tends to be a less accurate method just because it's based on how accurately you've set up the line and just a single frame's worth of data and just a couple of lines. You can add a couple more lines on that particular frame to make it a little more accurate. But basically, it's kind of a rough and ready approach. And part of the good thing, though, about tripod type shots is that even though you don't have the full set of 3D information, sort of no matter how you put things in, as long as it's a tripod camera motion, nodal motion, things are going to sit in the scene very nicely. So this is part 2 of this series, and it's our first successful way of solving this shot. Hi, this is Russ Andersson with part 3 of our series of tutorials on tracking this stadium type shot. So in this section we're going to show another way to solve this kind of nodal tripod shot, but this time using and generating 3D information directly. So rather than doing an automatic solve, an automatic track, we're going to do supervised tracking. So let's start out setting that up. And I'm just going to lay down a bunch of supervised trackers using the grid lines that are on the field. And the key point about this kind of shot is that you do know where many of the things are on the field if you go and look up on the internet how to lay out these lines on the field. And that information is widely available for all kinds of different fields. So this is kind of a ridiculously easy supervised tracking sort of shot. So I've set up my supervised trackers, and I'll just let them go through the shot. You'll notice that one of them goes off course. Now, if you go and you look at these things in more detail, this sort of thing happens to people all the time. And the most common mistake in supervised tracking like this is that people don't use a large enough search area on these shots. And you need to adjust the search area to compensate for how much the shot is moving around from from frame to frame. Now the one thing that we need to go and adjust now on this one particular tracker, since it shut itself off automatically during the first pass, we need to go and turn it back on. And if we let it solve through the rest of the shot, you see that's really what it needed. Now once we've set these guys up, we're going to go and lock all the trackers up. They won't be constantly resolving. And now we need to set up the 3D information for each of the different trackers. Now we're going to set it up with Y going larger and larger positive values to the back, and the usual convention is to have X going positive towards the right, so that means our X values are going to be going negative in that direction. So I just warn you that it's possible to do it a different way also if you want. This first point here is already at 0, 0, 0. That's going to be the origin. We'll leave that alone. The first point here then is going to be -5, and these are yards. This is -10. This is -15. Some of the different geometry of the lines, for soccer fields can be more complicated to figure out where things are, but not really generally very tough. So this first one here is at -5, and if you look up the right dimension, So 17.77 yards. So that makes the second one at minus 10 and 17.77. And minus 15 and 17.77. So there we have our basic values set up, but we need to configure these trackers a bit more for the particular solving mode that we're going to use. We're going to set them all to be seed points, which means they're going to be used in figuring out where the camera is to start out the solving process. And they're all lock points, because we've just entered X, Y, Z coordinates for each point. Now we go over to the solving panel, and we're going to change this to be from seed points mode. In other words, using these points that we just set up. So now we go and you need to do one other thing, which is to turn on this constrain checkbox so that this XYZ information that we just entered is used continuously as it's solving the shot. So now we rapidly get a solution. And whenever you do this, you should go over and look at the constrained points view. And you want to take a look at this last error column here and make sure that those error values are comparatively low. And that's just your feedback that you haven't made a mistake in entering the values or figuring out where things are supposed to go or so on. So the error should be quite low. And if you take a look, we've got the camera's position in the right spot, and we could go and drop something into the scene here. I don't know, put a pyramid in there or whatever. And the key point is that it's now in the scene in the right spot, so we can go and even add a couple other things in if we want. And so you get the idea that we have the correct 3D solution. And that's what, of course, we've been looking for. So even though, it was a nodal tripodish sort of shot, we can still do this, given that we can figure out where the things are that we're tracking in the shot. One final point on this actually was a handheld shot. It's not really on a tripod. The key point in it, though, is that the camera did not physically translate very far. It's just kind of being waved around in a somewhat different direction. And that's what makes it a nodal shot, the fact that it hasn't translated. So I hope you found this series of tutorials useful, and it'll help save you some time and aggravation, so you'll know what to do when you see these shots and what to look for. Thanks.